So we have our third question on the board. Now if you observe, the first one is a little bit simpler. So we are going from simple like that to now we are going, it's getting harder. But it's also very simple. Just understand the concept and the principles in solving implicit function. Then any question you see, you will be able to attempt it. If you understand how we find derivative of a function, then you will be able to solve any form of implicit function that comes your way. Now look at this. We have s squared plus 2sy plus 3y squared equals to 4. Find dy dx. Remember this for that's why I kept it here. Always remember that your answer will be dy dx is equals to something. Alright, so now this one is different from the first two we did. If you look at this one have two expressions attached to it, or two variables, x and y. So what we need to do here is to find the derivative of s and also find the derivative of y. And remember, when you find the derivative of y, we must include dy dx to it. Dy over dx to it. That is our pattern. So let us go. Now look at this guy. Of course, this is 2s. Okay, this is similar. All the questions we have s squared, but most times you can have other expression. I'm just using this one as an example. So then, if you look at this, let me put my plus here. If you look at this, we have 2xy. So I'm going to differentiate them separately. I will differentiate with respect to x. I will also differentiate with respect to y. Okay? So if I want to differentiate with respect to s here, it means I'm going to differentiate 2xy separately. So let's cover this and we assume we are differentiating only this 2s. So if I'm differentiating only this 2x, I will have just 2. But remember the y is here, so I will attach the y to it. So that is derivative of this because I'm differentiating with respect to x. Now, I'll come again. This time around, I'm differentiating with respect to y. So I'm bracketing this, I'm differentiating only this y for the respect to y. And of course, if I'm differentiating a single variable like this, it's just 1. It's 1, okay? So if I differentiate this, I'm going to have 1. Then plus this 2x will be there. 2x. This one is 1, but we don't write 1 because 1 multiply this, we are going to have the same 2x. But I remember I must introduce dy over dx because I'm differentiating with respect to y here. Okay, then plus for this, look at it, it's clear. If you are differentiating this guy, it becomes 2 times 3, which is 6y. 2 minus 1 is 1, so this is 6y. Equal to, if I'm differentiating this guy without just a single number, a constant. When you are finding derivative of a constant, it is 0. So you see, I find the derivative. Oh, sorry. Now we must have dy dx attached to that of y equals 0. Alright, so you can see now that we have done find the derivative of this with respect to x, and as well find the function of derivative of the y. Now what we need to do is to collect like terms. Of course, these two are together, these ones they are together. So I can simply put a bracket in this case so that I can move this one the other way around. So I'll retain my 2x dy all over dx plus 6y dy over dx equals, if this is going this other way, become minus 2x plus 2y. So here I can factor out what is common here. Dy dx is common, so let me factor it out. Dy all over dx, open a bracket, 2x plus 6y equals minus 2x plus 2y. Remember, let's bracket. So that I can divide this by 2x plus 6y. Bracket, so that this dy dx can stand on its own. Then I divide this by 2x plus 6y. So this guy will cancel this guy. So here I have dy dx equals, here, of course, we have a minus. So 2 can be factored out. 2x plus y. Then 2 also can be factored out. X plus 3y. So that 2 can cancel 2. So that our answer will now be x plus y all over x plus 3y. We'll bracket it. I remember there's a negative here, so I put negative as our answer. So this is the answer to this question. Okay, so as I said, always observe this. When you have like this kind of function, this type, what you need to do is to do them separately. Differentiate with respect to x, then that of y. Okay, and the one of y, do remember to add the y, the s. So this is implicit function when it comes to differentiation. Of course, in our next class, we'll look at the other topic you said I should look into. Alright, bye for now.